for some who cannot attend at all. And today I will show you the basics of the Unity editor, which we'll use throughout the whole workshop in order to do maybe scientific visualization, maybe some interactive 3D art, depending on which workshop you signed up. And since our group is not too large, I think we can do a lot of individual work here. So first of all, I need to connect to our wireless display.
I think it doesn't work well with two devices.
Yeah.
That's very strange. What if I put it for the way? Maybe it's interference.
Okay, technical issues. Apparently, our wireless projector doesn't like our wireless speaker.
Maybe it's a problem with internet.
Or a problem with it.
It's connection to the. Can you connect through the HDMI through the socket? Like use another HDMI?
Yeah.
And I can help. Let me just tell me about the cable.
Okay, so while we are solving the technical issues with the projector and other connections, I will briefly tell you something about myself. And of course, please let me know either in the Telegram chat or here in the Zoom chat in case you cannot hear me, or like if you have any questions or comments. So very quickly, I will share the screen. Probably sharing the screen. Great. And something you could have already seen on the workshop website. My name is Jiří. I have a PhD in computational plasma physics, which I obtained in Prague at the Faculty of Nuclear Sciences and Physical Engineering of the Czech Technical University in Prague. Czech Technical University is the third oldest still operating university in Czech Republic. It was established in the beginning of the 18th century. And my faculty, the Faculty of Nuclear Physics and Physical Engineering, was established in the 50s, 1950. Well, honestly, I don't remember the exact date. And throughout the years, it expanded to not be just focused on nuclear physics, but on physics in general, on mathematics, and on computational sciences.
Maybe you can say that Ivan Pluy, great Ukrainian, Czech, Deutsch physicist, also worked in your university and head of cathedral.
Yeah. So, yeah, thank you for that. My specialization was computational plasma physics, with specialization on laser plasma physics. And that's where you have a extremely powerful laser, and with that extremely powerful laser, you hit something, a small target which you have in your laboratory, and you watch what the target does. And since it's extremely high concentration of energy, it will heat up and expand, explode, and will be converted plasma, which is basically free electrons and ions, and such a cloud where there's a lot of electromagnetic interaction coming into play. And in order to study these systems, we of course need to do simulations, because not everything can be deduced from the laboratory setting. And those simulations are notoriously extremely difficult, large-scale simulations, where we use the biggest computers that are available in the world. And for example, for my PhD thesis, I did a simulation on a computer which was composed of about 12,000 CPUs. So imagine 12,000 laptops somewhere in a computer rack. And even on such a large computer, it took about 3 or 4 days to finish one simulation. And one simulation produced several hundred gigabytes of data. And then I needed to go through that data and to somehow find the interesting physics in that data. And there's, of course, many different ways to do that. But during the course of doing exactly this, searching through the data and trying to understand what's happening there, I got acquainted with 3D visualization, because I found out that it's very nice and instructive if I can take the data, put it in a 3-dimensional scene and walk through the scene and look what happens in there. Now, in part, I will show how to do this and show you some tools that you can utilize to visualize your data. The primary focus will not be on the specific ways to visualize the data, because that's very different for different scientific fields and for different types of data. So what I will focus on is to show you how you can use this Unity editor, the Unity, which I hope you already all installed, and which is used primarily, or was developed to develop games. Originally, I think it started in 2005, and originally it was just for iPhone games. But now Unity is one of the most important game engines, together with the Unreal Engine or the Valve Source Engine. So those of you who play games probably know all these names. So Unity is one of the biggest again. And the good thing, why I think it's a good thing to use it also in for scientific visualization is in this kind of setting, is that Unity gives you tools for creating those interactive scenes. Unity gives you tools to have a first-person controller. That means like that you can go through a scene like if you were playing a 3D game. Unity gives you tools to use a virtual reality headset, which I brought here and which is available or will be available here and at the university. For those who cannot participate online today, you can then let the university know and come here and try for yourself with the real hardware. And programming virtual reality from scratch is extremely difficult. And if you're a scientist, you don't have time to do that. You need to do your science. So that's why Unity is useful, because everything is already there and works. The second part of the workshop is focused on interactive multimedia art. And the way I got to multimedia art was that while I was working at the Czech Academy of Sciences, working on my PhD on those big laser plasma simulations, we hired my friend who studied multimedia art. And originally we hired him so that he would help us to create 3D models of the equipment we had there, a 3D model of the laser and the laser building, and somehow integrate the results of our simulations or results of the experiments into that large 3D scene. And one day he needed some help, because he wasn't a programmer, he was an artist. But in Unity, he was working in Unity, but he wasn't a programmer, and he needed something to do something in Unity which could only be done using programming, and he asked for help. So I looked at it, helped him, and I realized that Unity is actually very easy, that it's very easy to do interesting, visually interesting stuff in it. And first I started converting my 3D visualizations into Unity, and then through more help to this friend of mine, we started cooperating on artistic projects that he was doing. So my friend's name is Jakub Gross, and together we've been doing art installations since 2017. I think in 2017 we had our first exhibition that we done together, and since then we do at least one exhibition per year and combine our knowledge. Since then I learned a lot about different ways to approach interactivity and those visual arts, and he learned a lot about programming. Yeah, so that's how I got here, and I will briefly show you a couple of videos about the art installations that we are doing together. Those will be from Jakub's website, because I still haven't found time to actually create my website somehow. And yeah, so this is the first thing we made together, and I hope the internet connection will be good enough for playing the video. You can see we called it monolith. It's not good, right? Skipping. Okay. Somebody else.
It's slow frame rate.
Yeah. But it was a 4-meter high monolith cut in the middle, as you can see, and it was reacting to people putting their hands or whatever in the monolith, and around it were 4 headsets for virtual reality. If you put the headset on, this is more or less what you've seen inside the virtual reality. And you could also see the people reaching out inside the monolith. So the idea was that what you're seeing in the virtual reality is something that's happening in that cut out space of the physical thing. And yeah, it was part of a bigger exhibition which was done by a Czech psychologist, and somehow was intended to show the different layers of our consciousness and how these layers interact with the modern stuff, which was represented by our piece, by the monolith, and how it connects to the deeper order things like dreams and basically subconscious. That was in the back of the exhibition, but here I'm just showing our part. And yeah, sometimes you can see the virtual reality headsets around the sculpture in the middle. Yeah, so that was our thing in 2017, and we used, you might have noticed, those 3D sensors. Those were sensors from Microsoft Kinect. Maybe some of you know Kinect for gaming. They are like web cameras, but they're not just giving you the colored picture, but for each pixel of the picture, it also gives you the distance from the camera to the point a depth map, exactly. Yeah. So you can reconstruct, at least partially reconstruct, the 3D scene the camera is looking at, partially because it just looks from one direction. You can take more of them, put them around, and you will have a better 3D model. And Kinect is old technology. So nowadays you can do better with like laser sensing and in a much smaller package. And I brought one here. I will leave it here at the university, so you can also try it out if you come here in person. And okay. And the one I brought looks like this. You can see it's really small. It has a very nice resolution. It also, it's not too expensive. I mean, it's about 300 euros.
I mean,
Yeah, but still, for what it knows, what it can do, it's pretty good. And it can also see in the night because it has an integrated infrared laser, and it's good for getting those depth maps and those 3D point clouds for on distances of like 15 to 20 meters. The way we use it, or the way we used it with my colleague in the artistic setting, was this. So here you can see the 3D camera. There was also another one on those two are columns. So there's another 3D camera on the second column. So from the two 3D cameras, we get a pretty good picture of what's going on in the gallery. And then we put several projectors to have a projection on the ceiling, on the back wall, and on the floor. And we are taking the live streams from the 3D cameras, but interpreting them in some visually attractive way. So it's not just the pure direct recording, but you see that the scene has those silhouettes of the people walking in the gallery, and all the lines and all the boxes you see on the projection, each of them starts as one point read by the 3D camera. So they are, the points are chosen randomly, but they are not generated from nothing. They are actually generated from the real 3D recording that the camera is doing. And I want to teach you something similar. I want to show you how to use these technologies, how to connect the 3D camera to a computer, and how to interpret or reinterpret the image that is coming out of the 3D camera. Now, here live, in the live setting, we can use the camera directly, but those of you who are offline and those of you who don't have such camera connected to your computer will use a static recording or a static model that you will create using a mobile application called Polycam. And those who are in the art track, you will let me know afterwards on Telegram, and I can show you. I can help you do these 3D scans correctly. We will not need them immediately. We will need them for the second part of the workshop. So the first part of the workshop is today. We should end at 7 p.m. Yeah. So today until 7. So today we will cover the basics of the Unity editor, so that you know the software that you will be using. Then in next 3 hours tomorrow, we will cover more of the basics of the Unity editor, because as if you've already opened it, you've probably seen there's a lot of things. Most of them we won't need, but some of them we will need. And then we will split the groups into the scientific visualization group and the 3D art group. And for the 3D art group, that will be the moment where it would be good if you have your 3D models prepared. And for the scientific visualization group, we will talk about whether you want to have your own data, if you have something you want to have visualized, or if I just give you the model data and we will play with the model data. Okay, so I think this is this more or less covers the introduction about myself. If you have any questions. Oh, sorry, one more thing. I just wanted to quickly show you where I'm from and what I'm doing back home. So, as I said, I come from
You
Prague.
didn't share screen.
Oh, I didn't share the screen. Sorry. Sharing screen. Here it is. So I come from Prague. I hope you know Prague in Czech Republic, and I think the distance to Kiev was about less than 2,000 kilometers.
1,200.
1,200. Yeah. And I'm from Prague, but I work in Germany, near Dresden, not in Dresden, but near Dresden, in a small town called Görlitz. And it's a town on the German-Polish border, so it's half German called Görlitz, half Polish called Zgorzelec. And in this small town of Görlitz, there's this small, new, pretty new research institute called CASUS. And CASUS stands for Center for Advanced Systems Understanding, and it's a multidisciplinary center. My task there is to find mathematical models and ways to calculate those mathematical models on large computers in a way where it's useful for more than one discipline at once. So we're trying to find some universal models that work not only in physics, because I've studied physics originally, but maybe in some other fields as well. So we're doing physics, that's this matter under extreme conditions part, systems biology, that's mostly about the development of cells and the way cells operate internally. Earth system science studies the whole Earth and migrations of fish, for example, and other large scale. We're not specifically concerned with climate, but about the other living systems which are moving on top of Earth. Autonomous systems, that's mostly self-driving cars and drones. And digital health was something that was important during COVID. We basically started very early during the COVID pandemic. We started a COVID task force and made some advances in this kind of research, and not just the research, but we also did applied research, that we actually produced some apps that, for example, helped how to, if you needed to calculate how many people you should keep in the office and how many people should be in the on home office, so that your productivity doesn't go below some level, but that you still keep people safe. So we have a very wide range of fields we are studying, and we are trying to find commonalities between all these. So this is my my daily work job, and when I'm not working in Germany, sometimes I visit Prague, and in Prague, I, since the beginning of not the beginning of the war, but let's say after the invasion, I got somehow more involved through my friends who are either from Ukraine or have some Ukrainian root. I was looking for ways to help. So in my apartment in Prague, I was housing several refugees at the very beginning of the war. And since all of them already left and went back to Ukraine because they were from places where they could go back, I was still looking for some other ways to help, and one of the useful ways was to go to demonstrations in Prague and show our support to your country publicly. So here you can see me in front of the Prague Museum, and you can see that there's mostly women in the crowd. And what you cannot see, because it's not in the picture, is that in front of us there's a 3-lane road that goes through the middle of Prague, and across from the road there's an angry mob of vatniks and like pro-Russian idiots who are shouting at us and at those young girls, you know, and they're shouting like, Nazis, go home. And yeah. I mean, like literally, they were shouting, "Go home, you Nazi!" And then they gave the Nazi salute. I'm like, people, are you like really aware of what you're doing? Like, yeah. So this was, I think, in February, and or maybe March. This was in March, and since then, every month there's this pro-Russian demonstration at that very same place, and every month we go there, and actually what we're doing there is we're protecting the flag. So this is the Czech National Museum in Prague, one of the nicest buildings we have there, and you can see the Ukrainian flag at the very middle of the building, and it's something that triggers those pro-Russian vatniks a lot. So on that first demonstration, their idea was, we will go there and we will tear down the flag. And they actually tried. They really went there. And fortunately, there was a lot of police force who stopped them, but they fought with the police. Some of them got arrested. And since then, every month they want to go there and tear down the flag. So every month we gather in increasingly more and like bigger figures. And since then they didn't even try to cross the line between us and them. So this I think is from about 3 weeks ago or 2 weeks ago. Here we're in the front. This says Putin is fucked, like he's done. Pardeli in Czech, but maybe it's similar to some Ukrainian words, right? Yeah, I'm here now, and at the side, but still in the front. Here, this is at the side of the museum. You'll see it on the next picture, because at the end of the demonstration they decided, okay, we will go there and like tear down the flag. So we just like stood around so that they couldn't pass, but we were not alone. We were helped by the police. So through this line they just didn't dare. You can see this is the angry mob behind here, and here we are standing and not giving them a chance to come after the flag. So this is it. When I will go back to Prague, I will of course continue doing that as long as is necessary. And I also hope that we will stay in touch and continue working on whatever we start here. We hope so too. I want to say that I'm really glad I could come here and be here, because like I said, I was watching the happenings here through my friends and through the girls that lived in my apartment, and And of course, when you hear all those Russian idiots, what they say, even publicly in the news, and you want to argue with them, and sometimes they would say, "Huh, what do you know? Have you been there? Like, what do you know about how it's over there?" I'm like, yeah, I know because people told me, people I trust told me, but you haven't been there, right? So no, yeah, I've been there actually. So thank you for that. Thank you for the invitation.
And thank you for your that you actually suggested that and that you came here and are helping us.
Okay. I'm glad you liked it. Okay, so let's move on to the next part. And for the next part, I would like to quickly ask each of you about what you expect from the workshop, what you want to learn here. Very briefly, no need to. I mean, if you want to, you can give a long introduction. If not, just quickly tell me who you are, if you're here for the scientific part, or if you're here for the art part, or if you actually want to see both. And if you have any idea of what you would like to see, what you would like to learn. So maybe we can start with those who are in the room. Yeah, I will point the cameras on you guys, so you can start. I don't know if it will be loud enough.
What do you mean? Why we are here?
Yes, please.
Sharing of the screen so that it's bigger.
Oh, I'm sharing this. Okay.
So my name is Oleg. I'm working in Kyiv Academic University, and before the long-scale invasion of Russian to Ukraine, I worked in Dresden, not so far from Görlitz, and I hope to know something interesting, something new, and it's first offline event for me, such offline event since pandemic. So it's also cool.
Yeah, perfect. And you want to do more of this? You are like in for the scientific visualization,
Scientific, but I will
okay,
see
okay.
maybe.
And for the scientific, do you have your own data or just you?
It depends what data you need. What data we can visualize.
Okay.
I have a lot of data. I have a lot of data for electronic structure of materials, for example, for Fermi surface, for bond structure. And,
can it be converted to a list of either a list of particle positions, so like a list of 3D coordinates, or to a 3D field, a 3D.
It's already 3D, so
it's a 3D field.
Yes, yeah.
So
I visualize it. I can rotate it and see, for example, Fermi surface, and I show it to my students and free attenders like Vola how to do it.
So you have it, and is it stored as a field? So you have like a 3D coordinate and a value at each.
Yes, it's stored in files, but of course it cannot match the format you need.
Okay, that's good. No, I mean we can try to convert it. It shouldn't be that difficult. I know I shouldn't be saying things like it shouldn't be that difficult because we all know how these things turn around, but yeah. Okay. Please.
Well, I'm a student at Kyiv Academic University and actually also a student at Technical University of Dresden. So again, your neighbor.
Nice.
And by the way, computational modeling and simulation. So we are here on.
Okay.
I'm a beginner, very much a beginner, but we could be on par here as well. I was starting to get into 3D reconstruction, so and Unity as well, and I'd like to get insight into these topics. And of course, my choice are both scientific and artistic.
Okay. Okay. Perfect. Yeah. So can you please come closer because I cannot bring the camera to you.
My name is Ivana. I call myself transdisciplinary theorist, and I signed up for scientific visualization, but I'm also interested in art.
Okay, okay. And for the scientific visualization, what's your field? What's your field of science, or like the scientific visualization?
Transdisciplinary.
Transdisciplinary. But
Okay.
do you have some of your own data which you would be
Some
which
idea
you would
of
want, some
what you want
ideas
to
of data
see,
that
or?
you want to visualize?
No, I don't have my data yet.
Okay.
Okay.
But I will learn.
Okay.
Same here.
Because there's I mean, like I said, like the original or the main idea is to visualize this 3D, either those 3D fields, the spatial fields, or the particle positions. But of course, I know that some people said, for example, that they are working with graph-based data, and some of these we can do as well. But I would need to know about it in advance a little bit, so I can prepare it. Okay, so thank you. And now for the online participants, please start. Whoever wants to start, yes.
Yeah, let me start. So yeah, hi, my name is Natalia. I'm originally from Kiev. Currently, I'm in Germany, Jena. I'm a linguist, computational linguist, and yeah, I deal with vector representations of word meanings. And yes, they can be represented as a 3D vectors. So I'm looking for a nicer way of doing so, not just plotting them the old all the way. Yeah, I'm really interested in some better way of exploring the data in more intuitive way. Thank you very much.
Okay, thank you. Since I see you already have your data and you have some idea about how it works, and probably you also have some idea of what you want to do with that, I think we should connect later on in the Telegram group, and if you can then show me the sample of your data, we can somehow figure out how to transform it into something that we can easily use during the workshop.
Sure.
Okay,
Thank you. Thank you.
So, who comes next?
Dennis, maybe, because it's
Okay.
the only one who
Okay.
the rest
So
are either copies of us or
okay, so please, Dennis, if you can introduce yourself.
I think, Vova, you also did not introduce yourself.
Yeah, I can say a few words too.
Okay, yeah, sure.
I mean,
You're also participant.
Maybe Dennis will wake up until then. So yeah, let me. I can sit here and myself. So hello everyone. My name is Volodymyr Bezguba. I'm an organizer of this workshop actually, and I'm also participating here since I didn't use Unity in the past, so it's a new thing for me as well. I work in a similar field which was mentioned before by Oleg. It's solid state physics, electronic structure to be more exact, and in my case it's not simulation, it's real experimental data. So first of all I'm interested in visualization of data, like visualization of our ARPAS spectra, which can be like either 2D cuts, but also when you combine a lot of 2D cuts or use other types of spectrometer, you transform it basically into three-dimensional kind of point cloud. Which can be transformed into the HDF5. So it fits the workshop. I'm curious to see how it will be in the virtual reality, how it will look in the Unity. So in short, that's it. But also I will attend art probably too, because I'm curious to see how the 3D scanning works. That can help my work as well, because we do some of the sometimes we need to do the drafts of some vacuum chambers or other stuff, and it will be probably complicated, but it can be helped with this method that usually we'll be talking about later. So interested in both parts. So yeah, I think that's it. So now maybe Denis.
Is he online or not? We don't know.
We can't know. He's not responding.
Okay. So let's continue and
Is there a button like to pin him or
ask to unmute.
but yeah, if he doesn't respond, let's continue.
Yeah, let's continue. So I hope
my apologies. Yeah.
Hello.
Yeah. Hello. I'm at work now. That's the point why I wasn't able to join it offline, and unfortunately, I'm on a meeting with my colleagues concurrently. So my apologies for this.
Okay.
Inconveniences. But I can briefly speak about myself.
Yes, please.
Yeah, sure. So I'm a student. Not sorry.
All right.
Can I tell about myself a bit later then? In the end, maybe. Okay.
Okay. Yeah.
Thank you. Thank you.
Yeah. Okay, so let's start with Unity. I hope, like I said, I hope you all managed to install it and run the test scene so that you know that your laptops are fast enough to run it. And I would ask you to open the Unity Hub. Oh, and I might just decrease the resolution on my screen so that you can see better what I'm doing.
It's well readable right now.
Yeah, but just do this. Okay, so Unity Hub, we've already seen the hub itself. It serves to take care of the different installations of the Unity editor, because there's many versions of the Unity editor, and sometimes they are compatible, sometimes they are not. So sometimes you need to actually have many of the versions installed at the same time, and this tool should help you with that. You should already have some version installed. So we'll start with creating a new project. So you go to new project, and you will build a 3D project. And if you look at all the templates that are offered to you, there's this 3D core, but there's also 3D URP core and 3D HDRP core and VR core and AR core and many other templates which help you to start your project depending on the type of project you want to do. So here we will do the URP. Now, just quickly, what's the difference? So you have also 3D mobile, etc. So this 3D core project is really just the basic one, and it works well on desktop computers, on laptops. But if you want, for example, to run the same thing on a mobile, in virtual reality, it can be done, but it's kind of difficult to get all the important pieces in the project after you started through this. For the mobile, that obviously works on a mobile, but is difficult to run on any other platform. And those two are the ones we were interested in. So URP means Universal Render Pipeline, and HDRP is High Definition Render Pipeline. The differences are not important for us now, but you should know that this HDRP really produces a much better looking image, but it also needs fast hardware, a good graphics card, and most of it will not work on mobile platforms at all.
Technically, what is the difference like? How to explain that?
Okay, the difference is in the way it uses shaders, for example. The difference is in the support of the underlying graphics driver. So if for example, URP cannot do ray tracing. So if you have an RTX graphics card and you want to use ray tracing, which is cool for example, effects like water and reflections and things like this, then you need to use HDRP. But of course, then you need also to have this the appropriate hardware. Yeah, it goes down to, for example, DirectX or OpenGL shader level support and stuff like this. But for most, I mean, most of the time, it doesn't really matter if you use URP or HDRP. You use HDRP if you really need this like perfect visual touch. It's important for games. It's a little bit less important for us. And the benefit of URP is it's not like that much worse visually. And the benefit is that it has much wider platform support, and you can also run it on those laptops. Like for example, I have a laptop which doesn't have like a good expensive graphics card. Yeah, so I can still run and create those URP scenes.
Use URP for your visualizations.
Yes, yeah. All the examples I've shown are have been made in using the URP pipeline. So we want to start a URP project, then we first need to download a template. That should be quick. And after we download the template, it asks for a project name. So let's start. Let's say I call it KU Day 1, and a location. You can choose whatever you want. I prefer to keep those projects on the desktop because then it's easy for me to find them quickly. We click on Create Project and wait for Unity to start. This will take a while. So Unity will download the template is already downloaded. So Unity opens the template, but the template doesn't include all the parts. It only includes a list of the parts that then needs to be downloaded and initialized. So those are called packages or assets. So now it will download the packages, find the location of the packages. After it finishes resolving packages and downloading packages, it will compile the scripts and resolve the packages again. Sometimes it will.
Is it like that every time you create a new project?
Yes.
Or
It's every time.
Why can't it be optimized? Okay.
Yeah, good question, actually. So every time you create a new project from scratch, it looks like this. If you have, if you create like a template for yourself, where you already go through this and then save your project and open it again, then it's fast because all the packages have been downloaded. But it's only fast until you update your editor version. So if you update Unity and open an old project in Unity, it will do all these imports again. So it's I mean, Unity is a nice tool, but I have this love-hate relationship with it exactly because of this. So you can see my installation managed to load. That's good. So how are yours?
At iOS, it's still check the Unity app.
Yeah, okay.
Some security things.
Okay. Yeah. Well, let's wait. Everyone else, you're set.
Something up.
Working almost, resolving packages. How are you? Getting there slowly.
It has even several iterations of importing. It
Yes.
has import in iteration 3.
Yes, it's it's that's how it works.
Okay.
I
I mean,
it's, yeah, it's I mean it's normal for Unity. It's normal.
but then it still shouldn't matter much, because if you want to show it to someone else afterwards, but after you created it, you build it and you just get the working file. Which runs
Yeah.
without you.
Yes. So here we working with the editor. In the editor, you prepare your scene, you program it, and then when you want to publish it, you make a build out of it, and that's a single executable file or like a folder that you zip and distribute, and then like the final user doesn't even know that you are using Unity. It's just a regular application, whether on your computer or on mobile.
Can you take a look?
Yeah.
It loaded, it's all fine, but these errors, are they okay? Something with shaders? That's normal. Okay, that's fine.
So yeah, if what kind of graphic is it?
1650.
Wow. But we'll see. Okay, so you might get some errors about the like shader compilation or something like that. I think you can just ignore them. I also have those 3 errors. And okay, so actually these, I would say that these are coming from the template itself. So it's also not really uncommon that Unity Technologies publishes some templates and packages which should work, but you open them, you get a bunch of errors, and so don't be scared if in the end what opens looks more or less like this, and okay, maybe you have 1, 2, or 3 errors in the control. It shouldn't matter. So the online people, are you there? Did you manage to open Unity already with the new project?
Yeah, it works.
It works?
Yeah.
Works?
Same as yours.
Yeah.
Metal.
Perfect. Works. So online, should we wait for you, or yeah?
It works.
It works? Perfect. Okay. So I will continue. But again, please, one thing during the whole workshop, if at any time you fall behind a little bit, tell me and we can wait for a while. It's more important that everyone manages to get to the point where everyone else is than to move fast. Yeah, that's like that. There's not many of us, so I think we can manage. Okay, so when you open Unity and you open a new scene in Unity, this is more or less what you see. There are several parts of the interface, a part, of course, of the top menu, which you are probably all familiar with. There's several tabs inside the main Unity window. From the left, There's one which is called hierarchy, and you can see that initially it has something called sample scene open. Inside there's something called camera, light, and global volume. So this this sample scene is what we see in here in the window called scene. A scene is what it says. A scene, it's some location. For example, if it's a game, it can be a level of a game, but it can also be a menu or something like that. So different scenes are like different concepts of what you want to show. So here is the list of objects which are from which the scene is made up. This one is the main scene window. So this shows you a preview of the scene. And in the window, on the left side, these are some tools with which you can navigate through the scene while you're editing it. So this is, if I take the hand, then I can just click the mouse and move around. I can also use the mouse wheel, for example, to zoom in and out. With this tool, I can move the objects which are in my scene. This will rotate the objects which are in the scene. Scale, and that's about what we need. If you're using, if you're not in the, not using the view tool, but for example, you're using the move tool, which then allows you, if you click an object in the scene, it tells you which object you selected. So I selected the global volume, or here, if I click on the camera icon, you can see that it selected the camera and gave me those 3 large arrows. And if I click on the arrow and move my mouse, I will be moving the object around in the scene. And if I'm in this moving mode, which is one you will use very often, because very often you want to move move things around in the scene and rotate them, but you want also to change your view, your perspective. So what you can do is to use the middle mouse button if you have a mouse with a middle button, and if you hold the middle button, then you're again moving the scene around. Behind the scene tab is a tab called game. Game doesn't do anything yet, and it will do something when you click on the play button. So this is the previous. So in the scene, you're actually building the scene, you're building your game, and in the game window, you're testing the game, whether it works the way you want it. Now, of course, now if I click play, I don't see anything because we haven't done anything yet. So our game is just this empty window with a skybox, and that's what we see when we click play. Now you see that the play button has a blue background. That means the play mode is active. To stop the play mode, I click it again, so that it's gray again, and I can continue changing my scene and design my game. Sometimes you might want to see both windows at the same time, because you can be in the play mode, so testing the game, let's say, and moving something in the scene. So then it's good that if you can see both at the same time. And for that, you can, of course, undock or dock the tab just by grabbing it and moving it either somewhere like completely outside. So now it's a free window. And or if I take it again on the tab part, I can put it somewhere back here. Like if I put it here, then I have it side by side. There's also different layouts. You might find some layouts to be more to your preference. So here at the top right, there's this layout tab, and for example, for split, if you need to check your scene from all the different directions and from the perspective, or this 2x3, which usually is my favorite, where I see the scene window and the game window at the same time. And some others. Tall is for scene designers. White, I don't know, I never used it, but maybe you will find some use for it yourself. But let's just keep the default. Oh, and that's another important thing. If I just like put my tabs somewhere and make a complete mess of my view, and now I don't know what to do, I can always just click on default and get back to the layout I'm used to. And of course, you can save your layout and make your favorite one. That's the way I use it most of the time. But now let's just stick with the default one and continue with the part on the bottom left. That's the tab called project. So inside the tab called project, you see there's like some favorites. We don't have any favorites now, but there's some folders. One is called assets, the other is called packages. And here there's another window at the top, it says assets, and you see that it's actually the file browser. So here in the project window under the project tab, what you see are the actual files that are stored with your project. So this can be 3D models, this can be sound files, it can be images you are using for textures, it can be your source data, it can be many other things. And those are really like when I open the folder with the project, I see that there's this folder called assets, and you see there's this README asset, there's this universal render pipeline global setting asset, and all the other folders, sample scene. For each asset, there's two files. One is the asset itself, for example, this readme.asset, and a meta file with some metadata, which is automatically generated by Unity. If you take a new file and just copy it here into the assets folder, it will appear here in the Unity folder, and the metadata file will be automatically generated for it. The metadata files are just there, they're handled by Unity, so you don't need to do anything about them. Just know that they are there and belong to the project, that they are there and should be there. So assets are those unique parts of our project, our data, our creations, our scene definitions. Then the other folder is packages, and that's what took so long at the beginning when we are starting the project. Because when you publish the project, you don't need the packages folder can be completely empty, because there's a file that stores the list of the packages. So then when you open the project and it cannot find a package in the package folder, it will automatically download the package and put it in the package folder. So if you download some new packages and you're interested in files that are inside the package, you might find it here. But for the most part, we only need to be concerned about the assets folder and the subfolders in the assets folder. The subfolders are here, and so are the files. The last window is, the last tab is called Inspector, and Inspector shows you the details of a resource you've selected. It can be an asset selected from here, or it can be an object which is already present in the scene. So if I go back to our scene, you see there was a main camera, yeah? And we also found out that we can click on the camera icon and get some details about the main camera here. So the inspector window will tell me something about the object I've selected here in the scene hierarchy. So in this case, it's a camera. It has some interesting properties, and some we will look later. Same, another object here, the directional light, and the global volume. We don't need to know anything about it. But it's not only for the objects which are already part of the scene. You can also open or check the objects which are in the assets, and the inspector will just tell you some details. So this is the main Unity window, and I think we can start with a simple modification to the default scene, and we will add our first object. So, like I said, the scene. Okay, where do I found the sample scene in the assets? It's actually in the scenes folder, and there's this file called sample scene.unity. So I can also double click it. Oh, because I can also double click and open it. But it's already opened, and it shows this this asterisk here. That's because I made some changes to the scene. You remember I was moving the camera, so I need to save the changes using either Control S or File Save, or if I do some action that changes the open scene, like for example opening a scene, it will ask me to save it first. Okay, so let's save it. Why not? So now I have the sample scene open, and I want to add some custom object. I can click on the plus button here on the top right, and it gives me a list of different objects I can add. Instead of the plus button, I can also right click inside the object list, and here I'm again, this part is for creating objects. I can create an empty object or an object that actually does something. So let's start with a 3D object and select a cube. And as you probably would have guessed, it created the cube in our scene. You can see the cube in the scene window, and we can select it either by clicking on the cube in the scene window, or by selecting it here in the sample scene in the list of the objects which are in the scene. So first thing, we can rename it somehow, because let's call it a blue cube. Since it's not really blue, but gray, I think you guessed that the next task will be to make the cube blue. But before we get there, let's try to play with the scene again, with the scene editor window. So this was the way to move it. You can see my cube moving, and this was the way to rotate. If I click the rotate button, it will give me a sphere, and I can click on one of the axes on the sphere and then rotate by moving the mouse, and it will rotate along the selected axis. And the mouse movement is like somehow connected to the axis itself, but it's more like you move the mouse top, like bottom top or left right, and not really try to like do the circle as I mean, like it might look like you want to finish the circle, but it doesn't work that way. So
but we also have all the coordinates duplicated on the right, and for angles, are they just the degrees?
Yes, the angles are in degrees. So yeah, thank you. So yes, when we move the object or rotate the object, we should also watch what happens in the inspector. And here at the top of the inspector window, we have something called a transform. A transform is something that holds the position of the object, its rotation, and its scale. And you can see that it changes when I'm moving the object. Then the position changes, and of course, when I'm rotating the object, the rotation changes. So there's another way to place the objects. If I know exact coordinates, I can just input them here, and instead of trying to do it with the mouse. The cube has some other properties too. One of it is this mesh renderer. Mesh renderer is something that combines a mesh and a renderer. Mesh is specified here, and mesh is the shape of your object. So a cube has a cube mesh, and you can also create a different something, a sphere, and the sphere uses a different mesh, a sphere mesh. And if you import your own object, it will have some complicated geometry, and that geometry is stored as a mesh. So mesh is the shape of the object.
Mesh is graph data you were talking about, yes? Or
Not really. Mesh here, it's a 3D object. It's a way of specifying
3D model.
a 3D model. Yeah.
How to stored like straight.
There's very many different formats, and the ones that are used in Unity are actually like internal mesh formats that are being used in Unity. And if you have some other format, what you do is you import it. Then Unity converts it. Sometimes it knows how to read it, then it converts it by itself, and sometimes you need to find a converter plugin, or maybe you need to write your own. But here it's this is an internal Unity representation of the mesh. So the mesh is just specifying the geometry. It just says what's the shape of the object, but we want also to see the object, and for that there's something called mesh renderer. So rendering is rendering means displaying the object on a screen. And so here is the part that tells us what the object will look like. And from the most important for us is this part which says materials. So different materials have different properties, different visual properties. It can be on the way they reflect light. They can also emit light, and then can also light reflection also means that they can have different colors. So if I click on materials, I see there's some list with one element called element 0 and some material called lit. What's that? So this is some default material. If I click on it, it will open a browser which says which has a list of materials, and there's many of them, like this particle material, this lit material, which we're using now, and some others. But those are default materials that cannot be changed. They are just like placeholders, so that if you add some default cube, for example, that it appears as something. But we want to create our own material with our own properties, our own color, for example. For that, we go back to the assets folder. So here, because it opens something under packages, I have to scroll up, find assets, and here in assets, I right click again and go to create and find material. Yeah. So go to assets, right click, and create material. We can give him name. So I'll call it blue. And now, because I've selected this blue material, my inspector opened the properties of the blue material. And it's not blue yet. In order to make it blue, we change the color, which in the inspector for some reason is called input base map. But I mean, I won't go into all the details. If you are interested in something specifically, ask me. But there's a lot of terminology that's because here it's called base map, but tomorrow I will show you how to change it in a script, and there it will be called color for some reason. So now we click on the base map on this white patch, and it gives us a color selector, and we select some blue color. And now we have a blue material. Yeah? And now we want to apply this blue material to our blue cube because the cube is still not blue. So we click on the cube. And here, instead of using this original material, we want to put the blue one in. Now be very careful what you do, because when you click on it, it will take you back to the list of the original materials. Of course, we wanted to drag and drop. So we clicked on our blue cube, just found the material input box. Then we drag the blue material and drop it here. And our cube is blue. Now, if you open the game window, you should see the blue cube and the sphere. Maybe you don't see it because your camera is not facing the blue cube and the sphere. So in that case, I recommend moving the game window somewhere, for example, here to the side, so that you can see both. Selecting the camera, either by clicking the camera icon or clicking here the main camera object in the scene, and move the camera until your objects are well aligned so that you can see them. Okay, everyone managed? Nice. So I would say we make a 5-10 minute break.
Yeah, we can.
Yeah, that's because I mean, like, we're already 1 hour and 25 minutes.
But I mean,
So-
ask people if they want to. Do you
Yeah,
want
yeah.
a break?
Do you
or
want a
we
break?
continue?
A short one? Yeah, yeah.
Perhaps just to make a team.
Yes, exactly.
Yeah,
That
sure.
that was the
Let's
idea.
make it.
5-10 minutes. Okay. What about the online participants? 5-10 minutes break. Okay, let's make a 10 minute break. We continue at 17:35. Okay.
I'll boil some water for us. Come over here, everybody who wants to drink.
Yes.
Have a fine month tomorrow.
Okay, so welcome back, everyone. And I will share the screen and we can continue with exploring the very basics of Unity. And also, please just tell me if you're able to follow. You're able to follow. You are also there. Yeah. Okay. Cool. Is it not? So it's not too fast. Is it not too slow?
No,
Oh.
it's not too fast. Maybe sometimes a bit slow, but I don't know. It's
Okay.
it's individual. So I don't know.
Yeah. It's
But so far nothing complex.
okay. Good. I mean, it's the basics and
Yeah.
and just to just that you know your way around, and of course the more interesting stuff is in the second half, but we need to cover this before we get there. Okay, one more. Waiting for one more.
I don't know where I like it. You should know the time.
Okay, so we managed to make our cube blue. Remember that we had it in the scene window. We can move the cube around, and of course we could do something similar for the sphere as well. Now you've seen that when we created the cube, there's in the inspector, there's this transform. We've seen that the transform is not just on the cube, but the main camera also has a transform. Basically, everything has a transform because the transform defines the position of the object in the scene. The other, the list of the other properties of the object are also kind of hierarchical. So, for example, on the sphere, we had this mesh filter and the mesh renderer, something called a collider, which defines the boundaries of the object when it's colliding with some other object, because that doesn't necessarily have to be the same as the as what you see. The visual boundary of the object can be different from the, let's say, physical boundary, the one that tracks where one object hits another. And of course, the main camera, for example, doesn't have a renderer because you don't see the camera. The camera is actually the thing that makes you see. So in this way, the different objects have properties represented by different types, I would say. Those of you who know programming, these things are really types. There are different classes that you can attach to your empty object, and through the combination of the different classes, for example, the filter and the renderer, it makes the object do something. The other thing we can do with the objects is to group them in some bigger objects or object groups. And the way we do it is actually creating an empty object. So if we create an empty object, it will just give it the name game object. Why not game object? I will call it game object group. And you see that when I create an empty object, a game object in the Unity terminology, the only thing that is here is the transform, nothing else. What I can do is to make a group of objects, I just drag my objects onto this empty game object, and it will create a hierarchical structure where I have the sphere and the blue cube under this game object group. And if I select the game object group here in the hierarchy in the hierarchy browser, then when I move it, I move both objects at the same time. Just be careful if you click on one of these, then you're not really moving the whole group. Now I'm moving the single object. So this is the single object movement, and like this, I can move the whole group. So what does this look like in the game window? If I click play, what will happen? Well, nothing, because we have some objects, but they're not doing anything. They're not interactive. They're just sitting there. I can move them around, but just in the scene editor window. And the one thing I wanted to show you, if I do some modifications in the scene editor window, and I'm in a play mode, you can see that the position here changes as I'm moving the object. When I stop the play mode, this information will be lost and the objects will reset to the original state. So if you want to make the changes in your scene, if you want to move your objects around or rotate them, then don't do it while you're in the play mode, while your game is running, because then it's not impossible to retain the settings, but usually if you just modify something and then click stop, then it just goes back to the previous state.
And you cannot like click Ctrl S while you're in gaming mode. Maybe just wait now.
Well, okay, so what you can do, there is a way, but it cannot be done for the whole object at once. So for example, if I have this blue cube and I move it somewhere, then my transform has changed. I can click on this button and do copy component. So I can copy the component that just copies the properties into the clipboard. So now when I stop the game, I can paste it back. Again, clicking here and going to paste component values.
But can you say the whole state somehow? Because it's all
No.
People frequently like use game mode and editor mode at the same time.
Mm-hmm.
And how does this correlate?
You cannot save the whole state at the same
Oh.
time, because the whole state can be modified by script. So you're never sure whether that particular property was modified by a script and should get a new value, or if it should retain the value that was there at the beginning. Because the information about what the value was at the beginning is also lost in the game mode. So I mean, there are reasons why it works the way it works. It's just that you need to be aware of that. And when you do the modifications, you either have to remember that you've done the modifications, or you can copy paste, but just individual components. So if I change the transform, but at the same time, I also change the material, I cannot save both changes. I just have to remember one of them. So in general, it's like, don't do editing while in game mode. Sometimes you have to, because sometimes in game mode, something changes, you need to align something to
It's like it could be like game object, yes, it has a large game object, and it has maybe some rotating objects inside it. You move this large object somewhere elsewhere, and you need to save its new position.
yeah. But you move the object. Okay, you have an object
While
and inside.
it is rotating in the game mode, for example.
Yes, you can do that, and you will see the change in the game window, and we will see that shortly. But when you move it to somewhere and you stop the game mode, it will just reset to the original position.
And you cannot mend this, you cannot view this.
not not using the standard Unity tools.
Excuse me, can you show again how to make it blue?
How to make it blue? So, how to make it blue, or how to create the blue material? So, very quickly. Okay, let's. Our sphere is ugly, so let's create a material for our sphere. The visual properties of the object are defined by the renderer, by the mesh renderer, and specifically the color here is defined by the material. And so in order to change the color, I create a new material by going to assets, right clicking, for example, going to create material, that just create a new material, I call it red. And in the material here on the color, just an important thing, one of the participants didn't have this universal render pipeline /lit shader selected, and instead his shader said something like standard shader. That can happen to you. I'm not exactly sure how it happened, but it can happen. In that case, you won't found the color on the base map, but under some different name. So if for some reason you got the standard shader, then it will be under albedo. And another thing about shaders, if your shader is completely broken, like in my case, I cannot use the standard shader, I have to use the universal render pipeline lit shader. If your shader is broken, it will be this bright pink. Yeah, that is the color which says bad shader. Yeah. So here I go to the base map, and in the base map change the color, for example, to red. So now I have one blue, one red. And if I want to apply this shader to my object, I can, for example, take the shader or the material and drop it on the object. Or I can go to the sphere properties and drop it here to the list of materials. Or I can do it really manually. If I remove my old materials, now my sphere is invisible because it has no shader or no renderer. I click on plus, there's still no material called non-material. And if I click on this small circle button, it will give me a list of all the materials it would find in my project. And there's a lot of them coming from different packages, which are usually not interesting to us. I can find mine in there as well. Okay, so some other interesting properties can be, for example, found for the camera object. The camera, as I said, is something that renders the scene. That's what displays the scene on your monitor or some other display device. And one of the camera properties is, for example, the background you see in the scene. We have this gray bottom and this sky at the top. That's basic sky box, and maybe we don't like it. Maybe we want our scene to be like on a black background, and that's something that you set in camera settings. So if you open your main camera, go to rendering, go to environment, sorry, yeah. If you open the camera and go to environment, there's this selection box says background type. So instead of skybox, I can change it to solid color, like this, for example. And if I change it to black, then you'll notice in the game window that the objects are shining. They were shining all the time, but it maybe wasn't that much visible in with the skybox behind it. And this shining is actually a virtual light that's reflected of the objects, and that's another useful object that you can modify, another useful object that comes from the default scene you can modify, and that's the light here. It's the directional light object. So if I select the directional light and move it around, I'm sorry, that wasn't the light. I was so I was moving around this tool. I wanted to move around the light. This tool also helps you to orient your scene. So now we're looking at the scene from some specific angle, and if I click on the arrows here, I can see it from the top or from the side. That can help me, for example, to orient my light. And the directional light is just like shining in one direction. It's kind of like the sun. So if I want to see some change here in the scene window, I need to rotate it. So I switch to rotation, and you can see that the direction of the light changed, and that should be reflected. I mean, of course, I need to rotate along the correct axis. Like this axis just doesn't do anything. So with this, you can set up the lighting for your scene, which of course later can have strong influence on what the scene looks like. Because in the end, it's all about light, colors, and reflections. With the light can have a color as well. That's under emission. So if you go to the light, see the properties of the light in the inspector, and you can change the color of the light by applying a color filter. So I can just shine green on it, then you see that this strongest reflection change from white to green. So if you want to have some like mood lighting, like a colored one, this is the way to do it. And if you want some precise control over the white light, you can also change the temperature of the light, same as if you calibrating the temperature of the light or camera, or like if you using RGB lights to generate white light. This can be useful if for example, you're doing some installation with a projector, and together with that projector installation, there's also something else that emits some light. You have some other lighting in the room, and you want them to be the same color. So this can help with the shade of the things you see on the screen.
How can you change the scale of this picture? Because I don't use mouse, I just use
Okay,
and when I do
It's the
something,
same as mouse wheel. Mouse wheel. When you scroll up or down, it should
Yeah.
be.
yeah, when I do such thing with Mac, it don't work. So because my usually move to enlarge things. Mouse, yeah, mouse.
Yeah.
Mouse.
Yeah, I mean, it's
broad. No,
of course it's always much easier to work with the 3D when you're doing 3D and like in general computer graphics. It's much better to have a real mouse. Yeah.
Ну, воно не працює. Ті рухи, які я роблю зазвичай, щоб щось збільшити в MacBook, воно не
Ні,
працює.
а рухи, коли ти пролистаєш сторінку вниз або вгору, воно має працювати.
Це працює, да.
Ось, ну так, я собі типу scroll up, scroll down, воно має працювати. Як колесико миші.
Ну, скільки... А я, коротше, весь цей час сидів, у мене був один кусок, і я нічого не міг робити. Я? Це, типа, якась така, що правда, взагалі не питаю, чому робить.
You saw it, the colors of the skybox? I should mention, use the solid color for
How
now.
did you create the group? Because how do you add stuff to group? I was looking at it. I didn't see.
Okay, create empty,
Create something.
and then you drag.
Oh, and then it's like a group used. Okay, so
Okay, so now I think I hope you understand the basics of the things you can do with your mouse, mostly drag and dropping in the main window. And I would like to move to some interactivity and scripting. So my first question would be how experienced are you with programming? Is there anyone who has no experience with programming? No experience, no experience. Okay. So what you will learn now will be also the very basics of programming. So those who are experienced, I hope they will have the patience to hear all this again. I will not teach the whole basics of programming, just what's needed to add interactivity, some basic interactivity to the Unity scene. Those who are programmers would also definitely like to know what kind of programming language is used in Unity. So you have two options. You can use C# and you can use JavaScript. JavaScript is slowly being phased out. So the main programming language is C#. And it's
What about using C++? Is it possible to
It's-
get some plugins?
yes. Yeah, so C# is a scripting language used for the Unity scenes, but you can also create so-called native plugins, and those can be done in C or C++ or basically anything else that you can compile and then link to Unity. The standard procedure would be to have a C++ plugin as a native plugin and a wrapper that will allow you to call the C++ calls from C#. That's the standard procedure. But potentially it can be any other language too. But so the programming language we will use is called C#, and we write scripts in C#. Scripts are little pieces of programs that do some modifications. The interesting thing is that they do the modifications in real time, and so through this scripting, that's how you control the whole scene, how you make objects move, how you make them interact with one another. So let's start with a simple script. For that, we first need to create a new empty script. So we can do it here in the asset window, right-clicking, or going to assets, create, and C# script. We should give the script a name. It must be a unique name, so it's not repeated in other scripts, and it should start with a capital letter. It's not mandatory, but it helps if you stick to that. So let's call our first script, for example, change color. So capital C, change color. Oh, and a good idea also, don't put spaces and other special characters in scripts, in script names. Just use just like a single word with maybe some capital letters in the middle of the word, but don't put any. I mean, it's possible, but it makes things difficult later. So just stick with letters and nothing else. So change color. After we create this script, our inspector tells us there's a monoscript created, that its name is change color. And here, this is the actual contents of our script. Now, the script doesn't do anything. We want it to do something, so we will have to modify it. For that, we open it, either double click in here or click in open in the inspector. And when you do that, some sort of text editor should show up. So if you have, for example, Visual Studio, then it will open Visual Studio. Sometimes the Visual Studio got installed together with the Unity installation. If not, it will probably open one of your text editors. And you should see something like this. This is the script. So for everyone, did the script open?
Yes.
Yeah. So what's in such a script? First 3 lines says something using system collections, using some other system collections, and using Unity engine. Those of you who are not programmers don't need to pay attention to this, but just know that each script cannot operate on its own. It needs some connection to other libraries and
Sorry,
other parts.
I think something is wrong with streaming, because on Zoom I don't see that your screen got updated. I don't know why.
You're right.
You are stuck at the Unity scene. Just share the whole screen, I think.
I am sharing the whole screen. I'll share it again. Yeah?
Yeah, now it's
Okay,
nice.
okay. So first 3 lines. Those are the system imports. So you don't need to know about them, because every time you create a new script through Unity, it will give you this basic template. So this is where it calls some other packages that the script needs to function. For those who understand programming, you can see that this is a class, and that this class is derived from a class. This is the name of our class. It has to be the same name as the name of the file. So if you create a new script by copy pasting an old script file, you also need to change this name to be the same as the script file name. And it won't be done automatically for you, and you will run into trouble if it's not like this. So this the name of the class, what it says here, has to be the same as the name of the file itself. The name of the file itself, change color. Again, for the programmers, the class is derived from class called monobehavior, and monobehavior is a special class that allows the C# scripts to very tightly interact with Unity in extremely convenient and fun ways. The script as it is itself, like I said, it's not doing anything. And the reason it's not doing anything is double now. Or yeah, 2 reasons. First reason, it doesn't do anything because we didn't write anything in it yet. But even if we do, it still will not be doing anything until we somehow add it to the scene. Because now, if I go back to the Unity window, okay, we have it in the assets. In our assets, we have a new script. But in order for it to be active, we will need to put it somehow in the scene. And the question is where and how. So the how is simple. We will drag and drop it somewhere, and the where is we put it on the game object. So any of the objects here, but preferably on the object that we will want to modify with the script. Again, it depends on what our script will be doing. You can put it on the group as well, exactly. Yeah, and then it will affect the both objects in the object group. But in a way that's not completely trivial, but we'll see later. So for now, we need to do two things. We need to put our script somewhere and to actually start writing our script. So let's start with putting the script, let's say, on the blue cube. So we drag and drop the script here. And now if I click on blue cube and scroll to the bottom in inspector, I see that there's a new item, and it's the change color script. Yeah. Before we make the script actually change the color, I want to show you something easier, like the easiest thing we can have the script do, and that's to print some text into our debug console. Because that will also show us the two parts of the monobehavior script, the start part and the update part. In Unity or in like all the games, most of the game engines, the game is rendered frame by frame, and that's what makes it feel like it moves. And before you display each frame, you have to do a lot of calculations and run through a lot of algorithms so that the frame actually has, so that the computer knows what to put on that frame. And those two parts are somehow connected to that. So whatever we want to happen just once, on one time at the start of our game, we put here inside start. And if it's something that should happen continuously, it will be something that happen before each frame is being rendered into the screen. Then we put it here into update. So whatever we put here is just run once at the beginning, and whatever we put here is run continuously once per each frame. Yeah. So like I said, the first thing we will try is to put printing some text to the debug console. So we go between these brackets and write debug dot log. Now, mind you, it's important that the capital letters and the small letters are exactly the same as here. So if you would write debug with a small d, it will not work. It has to be capital D and then small dot, capital L, log. Then the regular bracket, parentheses. Then we input the quotes, the double quotes, and put some text in the middle. So it says debug.log, parentheses, quotes, hello, and we need to end the line with a semicolon. So if you have debug.log, hello, semicolon, you save the file, however you save the file in your editor, and then you go back to the Unity editor, and it should start automatically compiling the new scripts. And if everything went well, script should be compiled. You should see no errors here. So everyone fine or no? Yeah. You see an error?
Oh, it begins.
That's very cool. You install first script and your file is going to change color. This has to be the same. So either change the name of the file or change the name of the class. Yeah. So everyone else is fine, I hope. Now, if you've already put the change color script on the cube object, then when we hit play and when we open the console tab, we should see a message saying hello coming from object called Unity Engine Debug Log. Yeah, everyone? No?
Play.
Yeah. You enter the play mode and then you should see it. So, you don't have you change the scene. Okay, go back to the project. And,
Не перетягується.
Ну, ти ж не перетягнув.
click on default again.
Подивися властивості в інспекторі. Якщо в інспекторі вже воно є, то воно не буде виноситься. Ні,
ось сюди не перетягується.
Відкрий BlueCube.
Ага.
Просто, немає. Ти оце коли перетягувати, та він тут десь бережний. Ось він береш, перетягнеш сюди на це.
Ну, давай.
На BlueCube.
На BlueCube.
Да. І все. Тепер класний BlueCube. І ось тебе внизу десь повинно з'явитись поле, а воно не з'явилось. Ще раз нажми BlueCube. Ще раз нажми BlueCube.
I forgot to say, if you make changes to your scene from time to time, don't forget to save it. Because the scene is something like an open document, and if you don't save it, you can lose whatever you did. So save the scene with either file save
I can't
or with
drag
Ctrl
and
S.
drop.
You cannot drag and drop
Yeah,
the script. Okay, if you cannot drag and drop the script, there's another way to connect the script to your object. So, okay, if I go to the inspector and found the script, I can delete it, for example, remove component. So now my script is not there. And if I hit play, you will see that I am not getting the hello message. So another way, if I for some reason cannot drag and drop, I go here and I click on add component at the bottom of the inspector. So I have the BlueCube selected. I go to inspector, scroll down, find add component, and under script, I should see also the scripts that I wrote. So the change color script, for example. Dvojtečka, takže dvojtečka. Velký M, mono. Behavior. Okay, so everyone else has the script, and the script is printing something. Okay, good. Okay. So now, okay, we've seen that if we put something in the start part of the script, then it appears at the start of the game. When we hit play, we get this message, the single message, hello. So if we put something in update, it will run at each frame. Now, so if we put debug.log debug.
Hey, I tape play and I get message all compiler errors have to be fixed before I can.
Yeah. So if I put something here in update, save the script, go back to Unity, it should reload script assemblies, recompile automatically. No errors should be seen here. And now if I hit play, I will get hello, and then a lot of repeating messages, because whatever I put in update is just gonna be repeated all over again. So those who didn't get there,
Yeah, I didn't get, yeah. So I have here.
okay, click here.
Here.
It tells you that your error is on. Okay, open the script. Mm,
It shouldn't be problem. So
this dot shouldn't be here.
This dot, yeah.
Yeah.
okay, thank you.
Okay. So you're fine. You're fine.
Yeah, now I'm fine.
Share light
Okay, can you open so the script is it? Can you open the script, please? No, okay, should be here. Okay, probably. Play. Go to console. Yeah, and click this. Yeah. Okay, yeah. So sometimes I see that sometimes even the default installation of Unity has some different configuration, one computer to the other. It might happen that in the console you do not see the messages, so then you can change the type of displayed messages using these buttons. So these are the info messages, like the ones we put in. These are errors and warnings and like errors. So it's best to have everything on because we want to see everything. Now, if the log is too long, we can clear it here with the clear button. Okay, so that was like basic scripting, logging. And logging is important because it can give us some information about what is happening with our script when the script is misbehaving. And so now let's make the script do something more interesting than just printing to the log. And since we called the script change color, we can actually make it change the color of our object. Before we do it, I need again to come back to the to what an object is made of. So an object primarily is a type or a class called game object, and everything in here is a game object. What specific kind of game object, what subtype of game object it is defined by the different components you attach to the object. So you see, again, the cube is made of the mesh and the mesh renderer and the box collider, and now also the change color script. So those and we created it first by creating a cube from here. But we could also have created an empty object and manually add the mesh and the renderer and all that stuff, which just like would have been a little bit more difficult. And now if we want to modify something, what we modify is the component attached to a specific object. The easiest way to modify a component is to have a script which is directly on the object and is modifying one of the sister components which are on the same object. That's what we're going to do. But first, before we do it, we need to get the component. We need to somehow tell the script which component are we going to modify. For that, we need to know the name of the component. And the name of the component, we either read it in Unity manual, because we probably know what are we going to change, or if it's a component we made by ourselves, then we know the name already. So if we want to change the color, we need to somehow change something in the renderer, in the material, and change the color of the material. specifically for changing the color, it's easier a little bit. So we just need to find the renderer and tell it to change the color. Then it changes some sort of main color of the renderer. So we need to find the renderer component and change its color and change the color of the material on the renderer component. And just as it happens, the way to do it, okay, I will delete this part. I will open the script and delete this part that was login to the update. And we can leave this here. It doesn't matter, it just happens once. And let's first change the color at the start of the game so that we see that something's happening. Originally, my cube was blue, so that I can see some change. I will change its color to green. So first, I need to get the component I am going to modify. For that, I use a function which is called getComponent. So I write getComponent. GetComponent. Now I need to tell it what's the type of the component I'm looking for. And I'm looking for the renderer. It's the mesh renderer, but it's just called renderer. And I put the name of the component in angle brackets. So I do the left angle bracket, say renderer, and the right angle bracket, and empty parenthesis at the end. So this construction is calling a function getComponent, and it's telling it the type of the component I want to get. I want to get a renderer, and since I only and this is something I know that I only have one renderer, then I don't need to say anything else, and this is enough. It will give me the renderer of the current object. And when I get the renderer, I want to see to change some of its properties. Again, I can find it in the Unity manual, some documentation. What's the name of the property I want to change? I want to change the material, and it just happens that it's called a material. So I do getComponent renderer, the parentheses and dot material. That's gonna give me the material, and I wanted to change the color of the material. So I go do dot color. So what I want to tell the script is that the new color of this material should be something else. So I put the equal sign. So material colors equals, and I specify a new color somehow. There's ways to specify a new color. All of them are being done by a class called color. The class is with a capital C, so I see color, and I can either define the color using the RGB coordinates, or there are some predefined colors. So for example, color.green is actually the green color.
It's added because it's replaced.
Thank you. Like this. So getComponent, angle brackets inside angle brackets renderer, material.color equals color with capital C. Here there are all small letters. Yeah? Color.green. Let's save it. Go back here.
Object it should have it.
We applied it to the object, so when we call it, it reads.
I see.
It's like an implicit. It's like an implicit self pointer, which is pointing to the object you attach the script to.
Behavior of that class is invoked only for that. Yeah.
Exactly.
Now I understand.
Yeah.
Now,
I mean,
I heard it previously from you. Now I heard.
Yeah,
this and can.
Yeah, it became green. Yeah, it works.
Yes.
Yeah. So now if I hit play, it should become green.
But it changed the background from this like to black.
We did that previously in the settings.
Maybe
When you
I
press
made
play?
a lot of
And when you press play again, to stop the play to stop. To
Yes,
stop
it-
it changes back to normal.
Yes, yes.
That's just the bug of the driver or your
okay.
mark, probably. It shouldn't act like that.
So, okay, so now when we started, it changes to green. That's not really interesting because if you would start it like not from the editor, it would first change to green and then be green all the time. So now we want to make it interactive. So the simple thing we will do is we will read the input from the keyboard and change the color based on the keys we press on the keyboard. Yeah. So this is something that will happen in the update function. And as I said, the update function is being called at the beginning of every frame. So at every frame, what we will do is we will look whether the user is pressing a key. So we will try to read from the keyboard to see if the user pressed, for example, R. And if he pressed R, we will change the color to red. If he pressed G, we will change the color to green, etc. So for those who don't program, what we now need to find out is whether something happened. Did the user push the button or not? And if the user pushed a button, we will do something. If is the important word here. So we write if, and then regular parentheses. And now we put our question, if what? If a key was pressed. Again, we find this in the documentation, but now I will tell you that we're reading from input. So we're asking the input system whether there is a key pressed. So we ask get key down. Is there a key pressed? We're asking for a specific key that has to be pressed. For example, R. And that's again easy. We say key code. Key code dot and the name of the key. So for example, R. So what's this saying? If the user was pressing the R key, then something will happen. And what will happen? That's what we need to define in a block after this if command. Again, for those who don't program, a block is a piece of code which is between the curly brackets. So here, each of the functions, like everything that should happen inside the update function is inside the block that begins right after the name of the function and ends. Where the block ends, there the function ends. So we enter another block after the if condition. I open curly bracket and the end curly bracket, and between those brackets we write whatever, and it doesn't matter if the bracket is on the same line or on the new line. It just starts at the opening bracket. And here we say what we want to happen. So we want to change for R, we want to change the color to red. Well, we've already did it, so we can copy this line, paste it here, and just change green to red. Okay?
Yes, I have it.
Yeah, okay, so now we can, at the start, it should change to green, then we can change it to red, and then what? That's it. We can only change it to red. So to actually do something, we will copy the whole block.
Yeah,
So everything from, so we select everything from the beginning of the if to the end bracket, this whole block, we copy it, paste it here, and just change to another. So we say key code G, and that will make the color green. Yeah.
How to make the key toggle?
You will have to use another variable that stores the state.
Or like initialize it in start. Yes.
Yes. Yeah. And I'll show it later. Yeah. So if all of you have this, you can go back to the Unity scene. It will compile the script. You fortunately with no errors.
So it compiles it for some time, I mean a few seconds, but it's very easy script. So
Yes.
how much time it compiles real scripts for games?
Depends. Sometimes it only recompiles the script you have changed and then it's quick. Sometimes you will go make some coffee and come like 30 minutes later and it's still not done. It's really depends on the complexity of your scene. So if I now go play, you see I can click inside the game window, and when I press R, the cube goes red. When I press G, the cube goes green. Yeah? Yeah. Okay. So online, is your cube changing colors as well? Yeah, perfect.
I understand why I had the background, because I had changed skybox.
Oh, you changed the style.
So
Now it's the skybox all the time.
okay. Who's this? Okay, so I stop the game mode, and we had and we can have a look at some different interactivity, and now we will try to move the object from scripts. So moving the objects will, again, we have to write a script that changes something, and that something should be something connected to the position of the object. So now we are changing the color of the material, and if we want to move the object, we will be working with the transform. So let's create a new script. Create script and call that script move object. It will create a script called move object. I double click it, and now I want to move it somehow. So let's say we first try the easiest way to move, and that's to rotate our object along some axis. And for rotation, there is a function which is a method used by the transform object, and it's called rotate. That's very easy to remember. So, and it's something we want to be done continuously, so we put it in the update function. So first we need to get the transform and then apply some function on the transform. So we go to update and go get component. The component type this time will be the transform. And the parentheses. So this will give us the transform, and now we want to call the method on the transform. For that we use the dot operator. So we press dot, and the method is called rotate. Now the rotate method takes 3 parameters, and that the parameters are the speed of rotation along the one of the 3 axes, X, Y, or Z. So let's say we say 1, 0, 0. We delimit the the different parameters just by a comma. And also we need to put the semicolon at the end of the line. So get component, transform, regular parentheses, rotate 1, 0, 0, and close the parentheses and yeah. So let's save this. Go back here to our Unity scene, and
it keeps rotating it.
it keeps rotating. Yes.
But how do you set up the speed of rotating?
Yeah. Good questions. Like it's on lines. Here is the speed of rotation, and here's how to change it. So now I have this move object script, and I will put it on the cube. I mean, like I could put it on the sphere, but then I wouldn't see much. And so I just drag and drop it on the cube. It should appear here, move object. And if I press, if I hit play, my cube should start rotating.
And you can still change the color.
So it's rotating. Is it rotating for everyone?
RG, not here.
Oh yeah, of course. I can still push RG and change the color of the cube. Yeah. So now I will. So again, everyone is fine. For you, Václav, tebe to nefunguje. Okay. Thank you. So the question was how to change the speed of the rotation, how to select the speed of the rotation. Well, this number was the speed of the rotation, and it's in degrees. So it's 1 degree and 1 degree per watt. I've said that this function is called at every frame. So it rotates at the speed of 1 degree per frame. Now, let's say that we want to have an option to decide for each object which has the script what speed it should move at. For that, we use something for those no programmers amongst us that's called a variable. A variable is a place in the computer memory that stores something, a number, a piece of text, or an image or something. So here we will store a number, and we restore a decimal number with so-called floating point. And that's why the thing is called a float. And we want to be able to modify it from the outside, and that's why we make it public. So we make a public float. Those who program know what it is. Those who don't will just remember, if I want a number, I make a public float. So public float. Then we select some name for our variable, something like rotation speed equals, and we set some initial value. So let's say at the beginning we keep 1. Important thing, where do I declare the variable? It's like variable declaration. I declare it before I start declaring my functions, and in the block that belongs to the whole class at once. So in this large block, I put this rotation speed equals 1. And then here, instead of rotating by 1, I say rotate by rotation speed. So now it says rotate by rotation speed 0, 0. And if I change the number here, the rotation speed will change as well. But we will not change it here just yet. we'll save the script and see after we go back to Unity and it recompiles the script, we will check whether something else has changed as well. And we'll find out that yes, something else has changed as well. But in order to see it, we have to go to our cube object. Oh, sorry. Our cube object, scroll down. And when we find the move object script, a new field has appeared. It says rotation speed, and you can input the rotation speed here. And that's something I would like to tell the programmers mostly, because what you've just seen is that we've created a class, a regular C# class that just derives from mono behavior. And when I just drag the script which contains the class, when I drag it on top of a game object in the scene, its public variables are being shown in the inspector, and you can edit them in the inspector right here. Yeah. So now, if I save my scene and play it, you can see my cube is rotating fast. If I go to the blue cube object and scroll down to find the script, the move object script, and change the rotation speed here to 1, it will slow down. I can also do a negative number, -1, -1. I can put a large number, -10. I can put 0.1. But as I said, when I exit the play mode, the rotation speed will reset to the number that was set in the scene setting at the beginning. Yeah. So the last thing with this speed object, we will modify the variable at runtime, again, based on some key presses. So let's open our move object script again and go to the update function. And so we will keep this. We will keep rotating according to the number which is specified here in rotation speed. Yeah. But we'll add some other lines that will use the keys, let's say the Z key and the X key, and it will increase or decrease the rotation speed. So here we go again. If input dot get key down is key code dot Z, then we want to change the rotation speed. What does that mean? We want now in the rotation speed variable, we're storing the number 1. We want to store some different number there, a bigger number. So we say that rotation speed, we will be changing what's stored in here. So the new rotation speed equals something different than 1. And what it equals, we will just increase the speed. So it will be the old speed. So again, rotation speed. So here we read what's stored here. Now it's 1. And we store a new thing, rotation speed +1. And if input dot get key down is key code X, I could have copy pasted it, right? We do rotation speed equals rotation speed -1. Save it. Go back to our scene. It will recompile, hopefully without any issues. And when I hit play, I can then use the Z and X buttons to slow down or speed up the animation, and the R and G buttons to change the color to green or red. So
Nice.
I see we only have 10 minutes left, so I would say we stop here, because what I wanted to show next would be how to make the variable change in time, just based on the game time. And also there's one issue with this whole thing, and that's the rotation speed. Like if you all use the number 1 as rotation speed, it's still very likely that your cube is rotating at a different speed than mine. And because the angular rotation was specified per frame, so that depends on the frame rate. A faster computer has a higher frame rate, so it will rotate the cube faster. But that's usually not what you want. Usually you want the cube to be rotating at some like normal life speed, like, I don't know, do a full rotation once per second. And for that, we need to communicate the real time instead of this computer time. And there are some tools to help with that. And after I show how to read this real time, how to operate with the real time instead of the computer time in the scene, I will also show you how to do periodically happening something that periodically repeats. And next, I will also show you how to do switches and triggers. And then I think we will move into we will, yeah, okay, that would be like the basics. That's what I wanted to do during the first 3 hours, and I almost made it. And so for the next 3 hours, the plan was to input the gaming interactivity. So we will start with the first person controller. So what you know from the first person games, we will have an object that represents your player, and you
ASD or something like that.
yes, and you will play with ASDW or with the arrows, and you will look around with the mouse. And of course, we will not program this from scratch, because that's, I mean, it's not difficult, but it's like, why do it? Because probably someone already did it before and probably did it better. So we will import it from a pre-made Unity package. It will be a package actually made by Unity Technologies, and it's called standard assets. So we will import standard assets. And in order to import standard assets, I will have to also show you how to do package management in Unity, how to import packages, how to use the so-called asset store. And then from that, we will move on, because there's a lot of things that were already made by someone else. And if it's like, sometimes you want to reinvent the wheel, but sometimes you don't want to reinvent the wheel. And a first person control is exactly the point where you don't want to reinvent the wheel. So we'll instead learn how to get the wheel from someone who already made it.
So today you told us everything you planned, or less?
Almost. Like, let's say I have like 20 minutes left,
Okay.
but only 10 minutes left. So
Yeah, but then you need to fit even more
it's okay.
for the next 3 hours.
It's okay. It's okay. It's okay. I mean, yeah. So I would more like spend those last 10 minutes with your questions and comments. So are there any questions or comments from the online audience, maybe? Is No, everything fine, everything worked. Okay. Great. So see you tomorrow, Natalia. And or any questions from the audience here? No, no, no. Okay, then in that case, we will continue tomorrow, if I'm not mistaken.
Yep.
And like I said, we'll learn to add this basic interactivity, this first-person controller, and then we will also learn when we'll have the player object, so something we can move inside the scene, we will also learn how to make that object interact with other objects in the scene, because that's what interactivity means. Okay, so thanks for your attention and looking forward to seeing you tomorrow.
Thank you.
Thank you very much.